Hello and welcome to my tutorial on bond angles. So we're going to talk about valence shell electron repulsion theory, or VESPR theory. So all electrons have a negative charge, and each electron pair can repel other electron pairs. That's how it's all arranged like this on the electron shell arrangements, and electron pairs push one another as far apart as possible. So you get these funny shapes happening when you have more than one atom covalently bonded to each other. So like take bromine tetrafluoride, take bromine trifluoride rather, not tetra, because tetra means 4. Tri means 3. So we have 3 bonded pairs here. Now, looking at the periodic table, we all know that bromine is in period 7, meaning that it can hold up to 7 electrons in the outer shell. So 3 are being used, 4 aren't. So this means that a shape can be formed. This is the trigonal planar shape, as it has 120 degrees, and this comes about because it has 3 bonded pairs of electrons. There's 1, there's 2, and there's number 3. But if you look at methane here, it would have a dot and cross diagram something like this. And your hydrogens on the outside. That would be a tetrahedral one, and they would have a bond angle of 109.5. So tetra meaning 4, and that means it has 4 bonded pairs and no lone pairs. And in the case of sulfur hexafluoride with 6 bonded pairs, it has a 90 degree repulsion, as they're repelling each other equally, as sulfur's electron arrangement or outer shells have been completely filled by the bonded pairs of these bonding fluorine atoms. And the relative strengths of the repulsion, so lone pairs or unpaired electrons, as I've sort of mentioned earlier, bromine would have, in this particular one, 2 lone pairs, as they're not being used in bonding. And if you take water as an example, it has 2 bonded pairs and 2 lone pairs. So that's why it has a non-linear or bent shape. Although to say the word bent in an exam is like trying to say to the examiner, "Hello, Mr. Examiner, I'm going to be very, very rude." To put bent in quotation marks, but the best terminology to say for chemistry is to say the word non-linear or not straight, to avoid any sniggering over your exam paper. So if we look at ammonia, 107 degrees. So this would be a pyramidal, as it has 3 bonded pairs and a lone pair repelling it all like that. Methane is 109.5, as mentioned before, and water is 104.5. And what all these bond angles mean is that the lone pair to lone pair, this is in terms of each of the bonded pairs repelling each other, is greater, or rather less than bonded pairs, so I'll just put BP for short and lone pairs, or LP for short, but it's also not as strong as bonded pairs and bonded pairs. So it's safe to say that the bonded pairs repelling bonded pairs repel a lot more than bonded pairs and lone pairs than lone pair to lone pair. That's the order that you need to remember them, and in order to tackle any kind of question, it's best to draw a dot and cross diagram to see exactly what's going on in your molecule. So if we have one, take something with double bonds now, take carbon dioxide, where the open circles are oxygen molecules and the middle is the carbon atom. So this would be a straight molecule, or linear to say the technical word. Oxygen would have 2 lone pairs, 2 bonded pairs, and this is each side, remember. So carbon's completely satisfied in terms of electron outer shell fillness. So since carbon is in column 4 of the periodic table, it has 4 outer electrons, so the oxygen's coming along and forming 2 bonded pairs to it has completely filled the outer shell. That's what all atoms really want for Christmas. So if we take this molecule here, then we look at the periodic table, knowing that sulfur would have 2 bonded pairs. This is hydrogen sulfide, and 2 bonded pairs. It would have the same similar properties to water in terms of molecular shape, so I'm going to put the word bent or non-linear for this particular one. If we look at another one now, aluminium Tri Chloride, since we know that aluminium is ionic and chlorine is ionic, we would have the Al atom like that, and like that. So its shape would be pyramidal, but trigonal planar, as all the bonded pairs are repelling equally, just like boron tetrafluoride. Boron tetrafluoride also has the same 120-degree bond angle. So we look at a final one at these ions, which do need a dot and cross diagram to be drawn. So we have ammonium ions. So first off, you draw your ammonia in order to represent the dative covalent bond between the 4th hydrogen. You draw an arrow there, and have an overall plus charge and give it a bracket. So looking at the periodic table once more, we know that nitrogen's outer shell electrons are being used in order to bond. So it should have a tetrahedral shape. And an angle of 109.5. And if we look at SO3 now, page. So sulfur here, 1 oxygen, 2 oxygen, 3 oxygen, bond, bond, bond. It's always helpful to draw your bonded pairs in and then count the number of electrons that sulfur has used so far. Since it has 6, we have 1 lone pair of electrons. So, knowing that is 1 pair, we have pyramidal, and 107 degrees there. So, the way to tackle any bond angles is to draw a dot and cross diagram using the periodic table. We find out how many outer shells the bonding atom, i.e. the atom with no subscript here, and then draw it out like that. It's also very useful to learn the different shapes. So long linear is when you have 2 lone pairs, possibly, always 2 bonded pairs. Linear, 2 bonded pairs, no lone pairs, just like carbon dioxide. Tetrahedral, 4 bonded pairs and no lone pairs. Just draw that quickly. And trigonal planar, 3 bonded pairs, again no lone pairs. So, and for octahedral, if you have any using any bonding atom from oxygen to selenium or even tellurium and polonium, but polonium and tellurium and selenium are not usually used. It's either oxygen or sulfur in the exams. You could have an octahedral shape if they have 6 electrons. Yeah, if they have 6 electrons. So in period, anyone in group 6, column 6 rather. So that's a quick tutorial on the shapes of molecules and ions. If you want any more help, then I will put up some past paper questions, as actually doing the questions and looking at examples are quite difficult.